Welcome to lesson 6-9, page 219. This is for 5th grade, is multiplying decimals using the estimation strategy. Okay, this could get complicated, so let's break it down step by step. I'll try to take it as slow as I can while not boring you too much. Here's our example problem. 12.6 times 2.75. Now, in our previous lesson, 6-8, they gave us the answer to problems just like this, and our goal was to estimate in order to find out where the decimal point goes. Okay, so we're going to kind of hybrid that strategy a little bit. The first thing we want to do is estimate. Okay, so what can we round 12.6 to that'll be nice and clean and easy to multiply? I'm going to say 10. And what can we round 2 7/75 to? It'll be easy to multiply. I'm going to say 3. Remember, you want an estimate usually that's going to be a whole number, because whole numbers are a lot easier for our brain to process and multiply. Because look what we have now. Can you do 10 times 3? You bet, it's 30. So as an estimate, we have 30. Cool. So next step. Step 1 is estimate. Step 2 is solve without decimals. So we're going to treat 12.6 like 126. And we're going to treat 2.75 as though it's 275. So quickly, since this is not just a standard multiplication lesson, you can use traditional multiplication to figure this out, which is going to be a handful, or you can use lattice. I'll show you lattice. So it looks like we're going to get a rectangle that can accommodate 3 digits along the top and 3 along the side. We'll put 1, 2, 6 up above, 275 along the side. And don't forget corner to corner with these lines. Corner to corner to corner. Corner to corner to corner to corner. Corner to corner to corner. Corner to corner. All right, so now we have some fun multiplication to do. 2 times 6 is 12. 2 times 2 is 4. 2 times 1 is 2. First row complete. 7 times 6 is 42. 7 times 2 is 14. 7 times 1 is 7. 5 times 6 is 30. 5 times 2 is 10. 5 times 1, 5. Okay. 0. Add these two up. 2 plus 3 plus 0 is 5. I see 6, 10, 11, 16. Hopefully that's correct. 2, 6, 7, 14. Hear that 1, 3, nothing up here. So we get an answer of 3, 4, 6, 5, 0. All right, so you can tell our estimate was 30, but our real answer right now is sitting at 34,650. And this should be a red alert that says this is super wrong. There's no way our estimate should be here, and our real answer should be in the tens of thousands. But you have to remember, we took out the decimals. So here's the beauty of the estimation strategy. Just like our previous lesson, which I believe was 6-8, if you look at your estimate, which is 30, we can take our real answer and decide which decimal place would make the most sense, which would get us closest to our estimate. Again, right now we're at 34,650. But there is one spot. If we put a decimal right here, what do we have? We've got 34.650, also known as 34 and 65 hundredths. I'm going to ask you, that's a little over 34 and a half. Is 34 pretty close to our estimate? You bet it is. It's going to be as close as any other decimal placement. You know, if we put one after the 6, it'll be 346. We're in the hundreds. But what we did is we found the perfect spot for that decimal to get them as close as we can to the estimate. Okay. I'm trying to think, should I try number 1, at least point you in the right direction? Maybe we should take a look at page 219 and see if we can put this to use. Let me try to frame all this, so if you need to freeze the picture, you can look and double check how we did it. Okay, let's take a look here at 219. So they walk you right through the steps. It tells you step 1, make an estimate. Step 2, multiply as if the factors were whole numbers, as if this was not 76.1, but 761. Don't do this one as though it's 9.6, but treat it like 96. So number 3 is to use your estimate to place the decimal point of the product. So why don't we do this? Why don't we go ahead and estimate, and then I will let you guys try to find the answer for the whole number, and then we can figure out where the decimal point will go. So what can we round 76 to? This is a rough one because I'm tempted to go to 100, but I'm looking at 9.6. I know he can probably be rounded to 10. So if that's true, I can round a lot of things by 10. I might just go ahead and round 76.1 to 80, because I know I can do 80 times 10. That's as simple as 8 times 1, and then add in your 2 zeros. So your estimate is 800. Your next step, and I think this is where I'm going to leave you to see if you can handle this. Next step is to multiply as if the factors are whole numbers. So take that 76.1 and just turn him into literally 761. And then take that 9.6 and just turn them into 96. And again, you can do that in traditional format here, like that. Or you can set up a lattice problem on a separate piece of paper, or if you have enough room here, it would look like this. Three columns for each digit above, 2 rows for the 9 and the 6, corner to corner, 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 corner. So however you want to solve this answer for real, we're going to treat them like they're whole numbers. We're going to do just a regular old multiplication problem. And whatever your answer comes out to be, my guess is it's going to be way higher than 800. You're going to use this 800, this guide, to find out where your decimal point should go. A hint, if your estimate is 800, your decimal should be placed somewhere that's going to put you in the hundreds, if possible. Okay, I want you to give it a shot and let me know if you have any questions. This is it's a tough one, guys. So hang in there, try your best. If you need any other guidance, again, YouTube is a wonderful trove, or even Khan Academy. Just search multiplying decimals using estimation. All right, guys, next time we talk, we'll be discussing the second strategy, which is going to be even more interesting. All right, adios.